Right, so determining sample size. Suppose a sociologist wants to determine the current percentage of U.S. households using email. How many households must be surveyed in order? How many? That means we're looking for sample size. To be 95% confident that the sample percentage is in error by no more than 4 percentage points. And then it says, use this result from an earlier study. In 1997, 16.9% of U.S. households used email. Now, do you think that's an accurate figure for today? No, probably not. I think it's gone up a little bit since then. But we're going to use it as a starting point for A, and then in B, we're not going to assume anything. So we can compare the two sample sizes. So let's see what we have given. So how many means we're trying to find out what N is. We're 95% confident. That is our confidence level. And that's going to determine our critical value. What was that critical value that corresponds to a 95% confidence level?
97.5? 1.96.
So the percentage is 97.5 and 1.96 is the critical value. Yes. So that's the value that has 97.5% on the left, so we do the inverse norm of 0.975. Okay, so then the next thing we have, we want to make sure the sample percentage is in error by no more than 4 percentage points. What is that? Really what that means is we're going to take our sample proportion, we're going to add 4% to it and subtract 4%. That's our margin of error. Right, so E is equal to 4 percentage points, so we change it to 0.04. So for the sample sizes, many times it's given like that as a percentage. Okay, so a sample size, we said, is equal to our critical value squared times P hat times Q hat divided by the margin of error squared. And in the first part, part 1, we're going to use our estimate for P hat. So what was P hat? Yeah, it's our 16.9% change to a decimal, so 0.169. What's our Q hat? One minus that, right? So that's 0.831. Okay, so 1.96, our critical value, times our estimate for our population proportion. That's an ancient one, but we'll still use it, divided by our margin of error squared. So both the Z alpha half is squared as well as the E is squared. So make sure you don't forget that. So we can enter all this at once into our calculator. 1.96 squared times 0.169 times 0.831, and all that divided by 0.04 squared. Says we have a sample size of 337.19. Our rounding rule for our sample size, this is the only time where we always round up. Okay, the reason why we want to round up is because we've predetermined that we have a certain confidence level and that we have a certain margin of error. So we want to make sure that we absolutely meet that criteria, and that's why we always go up. So even though rounded, this would be closer to 337, we still round it up to approximately 338. It's always going to be a whole number. Now, I think there may be one question on your homework where it asks you to round it versus rounding it up. So just pay attention to that on your homework. So this is part A. Part B says use no prior knowledge. So this is where we're looking at the worst case scenario, and we said our area is largest when both P hat and Q hat are equal to 0.5, and 0.5 times 0.5 is 0.25. and that divided by E squared. So the only thing that changes is our estimate for P hat and Q hat. So 1.96 squared times 0.25 divided by our margin of error squared, and that is 1.96 squared times 0.25 divided by 0.04 squared. Okay, our sample size is now 600.25. Since we have to round up, that is 601. So this is how you find the sample size given a proportion. Okay. I also wanted to show you guys two quick formulas over here. And then I'll have you guys do a couple examples on your own. Okay, so the point estimate of P hat. So let's say we already have the confidence interval and we want to know what is P hat. Remember, P hat is your sample proportion. So where would it be located within your confidence interval? Right in the middle. So how do we find the midpoint of an interval? Yes, average the two. So add them up and divide it by 2. Now the margin of error, that's the number that we subtract and add, right, to get that lower and the upper limit. So what we want to do in order to find the margin of error, we want to take our range of values and divide it in 2. The range of value is our maximum minus the minimum divided by 2. So both of these formulas make sense. So do the upper confidence limit minus the lower confidence limit divided by 2. And then here are 2 examples below that. These, by the way, are not proportions, because proportions are always going to be decimal numbers between 0 and 1. But regardless, we can still find the point estimate by adding these two together. So 5 plus 10 divided by 2 is 15 divided by 2, which is 7.5. Or the other one is taking the range and dividing it by 2. The range was the upper limit minus the lower limit divided by 2. That's 5 divided by 2, or 2.5. So 7.5 is right in the middle. When we subtract 2.5, we are at the lower limit. When we add 2.5, we're at the upper limit. And those are the 2 type of questions we're also going to solve over here. So we're going to go back to our other worksheet. And I'd like you to answer questions 4 and 5. And then also a couple for the sample size, which is question 8 and 9.